Hi, welcome back to the 2015 AP Calculus exam. We are going to take a look at question number 6 from the AP, and this is a Maclaurin series. Now we should hopefully remember that if it's Maclaurin, they're telling us that the center is 0, and they say that the series can be given by our series for our function f, that the function f can be represented by the following Taylor series, or Maclaurin series here. And they give us the first 1, 2, 3 terms, and of course the general term right there. And we're told that it's going to converge for all x's within a certain radius of convergence. And matter of fact, the first question here, they actually tell us to use the ratio test to find that radius of convergence. So we should remember what the ratio test says. Remember, that's the limit as n goes to infinity, a sub n plus 1 over a sub n. Right? So, and we want this to be less than 1. So therefore, if I start writing it out as n goes to infinity, using my general term, I'm going to look at the next term, the n plus 1 term. So this just becomes negative 3 to the excuse me, negative 3 to the n. Because the plus 1 minus 1 just cancel each other out. Negative 3 to the n times, this becomes x to the n plus 1 over n plus 1. And now we're going to divide it by the original. So I'm just going to invert and multiply. This becomes n over negative 3 to the n minus 1 times x to the n. Remember, don't forget, this has to be less than 1. You have to show that, and don't forget the absolute values. Cleaning this up a little bit, we get the limit as n goes to infinity. Now, if I have if I take n minus 1, the n's are going to cancel, and this just becomes negative 3 to the first. So just negative 3 is what we're going to be left with. Times, looking at the x's, the n's are going to, we're just going to be left with just x to the first, and be left with this n on top, and this n plus 1 on bottom, be less than 1. Now we know from earlier, from a review, you can take a look at my notes here, at a previous video. Anything that does not have an n is going to get factored out. The 3 is already positive, so I can just write this as 3 times the absolute value of x. So the absolute value of x being what we can be kind of looking for here, and times, and anything with an n is just going to stay within my limit here. Stay within your limits. Of n over n plus 1 has to be less than 1. Solving for this, this is just going to be 1. So therefore, what we're left with is 3 times the absolute value of x is less than 1. Solving, we get the absolute value of x is less than 1/3, and there is our radius, right? It kind of matches up with our equation now. So therefore, we can say the radius of convergence is 1/3. Now, remember what that radius means. If I'm at 0, if anywhere within 1/3, either way, plus or minus 1/3, will guarantee to converge. Now, now they're not asking for it here, but they might ask for, well, what is the interval of convergence? Well, anything within plus or minus 1/3 will converge. But you still have to check the endpoints to see if the endpoints would converge, okay? But that is not what they're asking for here. So we're done right there. So how many points is this worth? Plus 1 for setting up your ratio, plus 1 for getting your limit, and then plus 1 for writing out your answer. It's 3 points. Now, if they were to ask you to find the interval, it'd be worth another 2 points on that. All right, part B. It says, write the first 4 non-zero terms for the Maclaurin series f prime, the derivative of f. Express f prime as a rational function. So let's not even worry about this. Let's just stop here for now. Then we'll go there. Period means stop. Okay? So I know what f of x equals to. So they're saying f of x equals this x minus 3x squared, 3 halves x squared plus 3x cubed minus dot dot dot. And it keeps going and going and going. That's like the inner. So we want to find the derivative. So I'm going to do that. I'm not worried about, so I'm just going to find my derivative. F prime of x would equal, we just want the first 4 non-zero terms. We don't want the general term. They're not asking for that yet. Okay, so we just want the first 4 terms. If I take the derivative here, we're going to get 1. This becomes minus, what's that? Sorry, dropped my pen for a second. So we get minus, bringing down the 2. The 2's cancel, and we get 3x plus, this becomes 9x squared. Minus, now we only got the first 3 terms, so we have to get the next term here. I have an option. One, I could just, there it is. I could just take the derivative of this, or I can just take a look here. My first term is 1. I'm multiplying by negative 3x here, and I'm multiplying by negative 3x here. That's a common ratio, negative 3x. This is geometric. So my next term is going to be multiplying this by negative 3x, so minus 27x cubed. Now, we're going to stop here, okay, because they only want us to write out the first 4 terms, so we should probably say approximately. Okay, but next they say express f prime as a rational function. So that's part 2. F prime as a rational function right there. So to get f prime as a rational, I know my rule. That's just this a sub 1 over 1 minus r. That's all we have to do. So therefore I could say f prime of x would equal, this comes from our shortcut for rational functions. It's because it's the infinite sum, right? And we'll go over that in a second here. So my first term is 1 over 1. This becomes plus 3x. And there it is. Remember, a series goes on forever and ever and ever, a sub n. So because I know this is geometric, this is the sum of an infinite series. That's the sum of an infinite series right there if it goes on forever. Well, if it's geometric, this is also the sum of an infinite series. So if that's an infinite geometric series, a sum of infinite series, so if I know it's geometric, I can use my little shortcut to write the function out. And there we have that. All right. So how many points would this be worth? You would get 2 points for the first 4 non-terms. 2 points here, and then 1 point for your answer right here. All right, the last one, part C. Write the first 4 non-zero terms of the Maclaurin series f of x, e to the x. Use the series to generate e to the x. E to the x. So we're going to write the first 4 non-zero terms of e to the x. So e to the x, we should know this is one we memorize. 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. Don't forget the plus dot dot dot. That is one thing we can do up here too. See, instead of putting this equal sign, approximately I can just do this. And that's probably a lot better to write it that way. Use the Maclaurin. Now notice, I made a mistake. I'm taking my test. I made a mistake and I realized, oh, I should go back and kind of fix that if I can. Use the Maclaurin series for e to the x to write the 3rd degree Taylor polynomial. So 3rd degree Taylor polynomial. This is a polynomial this time of g of x, which is e to the x times f of x. All right, this is going to be nasty. So now we're going to say e to the x times f of x is equal to, well, what is e to the x equal to? 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot dot dot. F of x, well, that's our original function up here. That's going to be, what's that? X minus 3 halves x squared plus 3x cubed minus dot dot dot. And we only want the 3rd degree Taylor polynomial, so I'm going to go P3 of x equals. So that's e to the x f of x. I'm only looking for the 3rd degree. So that's going to make this a little bit easier because anytime my degree gets bigger than 3, I'm done. So we only want degree 3. And I'm going to distribute. 1, if I distribute the 1, I'm going to get x minus 3 halves x squared. Whoop, that should be x cubed. There we go. Plus 3x cubed. The next term is going to have an x to the 4th power. I only want a third degree power. Then I'm going to distribute the x's. Plus, distribute the x, I'm going to get x squared minus 3/2 x cubed. I'm not going to distribute here because that's going to give me an x to the 4th power. I don't need that. Next, I distribute the x squared. That's going to give me plus x cubed over 2 factorial. And again, I'm not going to distribute here. That's going to give me an x to the 4th power. And my last one here, I'm not even going to distribute that at all. That's an x to the 4th. So I'm done. That's it. That's my third degree Taylor polynomial. And you can clean this up if you like, but you know what? I'm not going to do that. You can do that if you like. So I mean, you get 1 point for writing your Taylor, and this is 2 points for your for e to the x. I'm sorry, and you get 2 points for your polynomial. All right, hope you enjoyed this series. Again, please go back and make sure you fix part C. Make that an equal sign and put the plus ... at the end. I'll see you guys later. Bye bye.